Okay, we still have people coming in. I understand that interstate got backed up a little bit. We have 42 RSVPs, and this room holds 47, so we're going to be a little tight, but there's still some chairs up front, so everybody should be able to make their way in. I'd like to welcome everybody. I'm David Spakes, and I'm the organizer of the STFK Science Cafe, and this is organized by, or sponsored by Spirit and Truth Fellowship in Knoxville and the Associated Professionals Think Tank. And David Fox here on third row is heading up the Associated Professionals Think Tank, and he'll tell more about that at the end of the meeting. So, how many, just by show of hands, this is your first time to come to one of our meetings? So, about 6 or 7 there. So, we're special welcome to all of you, and we do this once a month, and it's a different topic every month. It's a different speaker every month, but it's always something very interesting, and I hope that you'll come back and enjoy more of it. So our topic today is living volcanoes, and Annette Engel is our presenter for today. Let's give Annette a hand. Yay. Professor E.T. in the Earth and Planetary Sciences Department. I originally was trying to recruit her for a couple of years ago to come and talk about another topic, and hopefully we'll do that later, but she told me about her more recent work, and we were so fascinated by that we decided to go ahead and do that topic first. And she'll be up here in just a moment. What we're going to do, the way our meeting will start out is we'll watch the video that we have first. It's about 10 minutes long, and this is taken from a clip of the Nature program from PBS Public Television. The title of the episode is actually called Living Volcanoes, and Annette is actually in some of the clips because they did the filming in Hawaii earlier this year when Annette was there. So there's another speaker that does most of the talking, but she's kind of lurking in the background there, and they were working together on that. So she was actually on site when they did the video. After the video is shown, then we'll open the floor for questions. And the important part about this meeting is you get to ask questions, because that's what makes this meeting so much fun. So while we're watching the video, be sure and think of some really good questions you want to ask, and then that's the rest of our time here. We don't have any young kids with us here today, but if you know anybody that has any children from age 5 to 12, and you think they might be interested in this, or interested in getting their kids exposed to science, we want to encourage young people to get interested in science and to pursue careers and be thinking about pursuing a career in science. So for age 5 to 12, we have a kids cafe that happens at the same time. There's a kids area in the library, and the kids would go with my wife back there. She comes prepared for any kids. But it's not just babysitting. She has a science lesson. Today it would have been about volcanoes and some hands-on activities and so on. So if you know anybody that would be interested in that, we really want to encourage our young people to get interested and involved in that. Today's Living Volcanoes, I'm going to tell you about a couple of the topics that are coming up. In the month of September, we're going to have a meeting on sinkholes. And we have a lady who's a professional geologist that works in the area. She'll be a returning speaker to talk to us about sinkholes. In the month of October, we have a lady from Oak Ridge National Labs is going to be coming and talking about mirror matter. And there was a big article, if you go look it up, you can Google it and read about it, and they're talking about, she's looking for parallel universes. It's very awesome. She says, well, it's not really as fantastical as that. That's science fiction. She deals in science fact, but it's kind of bordering into that realm, into that area of far-reaching research. So if you're interested in that sort of thing, mirror matter, that will be in the month of October. We don't have a speaker yet for November, but we have in December we'll have
Stephen.
Thank you. Stephen Lynn Bales. I was trying to remember the name of the bird that he has.
Oh, my God.
No, I don't mean his real name. I mean the type of bird.
Kestrel.
A kestrel. Thank you. It's a type of falcon, and so he's going to actually come and bring the falcon. He is licensed to care for it, and it's not able to be released back into the wild. But he'll come and talk about that and how the populations of birds of prey, you know, they declined and now they're bouncing back, except this particular type of bird, is kestrel. So that'll be interesting. That'll be in December. And then we actually have a speaker all the way up into March of next year. She's a geologist that was in Iceland doing some study there, and she wrote a book about the geology of Iceland. So that's going to be in March of next year. So a lot of good stuff coming up. You can go to our website, knoxsciencecafe.org, and see the full schedule about all the speakers and stuff. All right, anybody have any questions before we get started? If you've never been to the library, out the door and just straight across the hall is the restrooms. And if you haven't found the snack table or the drinks, you can at any time refill your glass or grab a can or a bottle and grab a snack. All right. Any other thoughts? Have I missed anything, dear? No? Okay. All right. Well, let me get this video started. And this is Living Volcanoes.
We live on a restless planet. Every day on Earth, around 30 volcanoes violently erupt.
But what we see is that as the forest recovers eventually, then you have insects that also move underground. And so it's a cycle.
And today, the cycle of death and creation continues on in Hawaii.
Okay, watch your eyes. Again, if we had any kids, this would be the time when we would ask them to ask some questions, but if not, we'll just ask Annette to come forward. Let's give her another hand.
Have any of you seen that video?
Was that you in that?
No, that's my call. Or this is
Oh, yeah, push the button forward.
that's my colleague Megan Porter.
Oh, okay.
She's a professor at the University of Hawaii,
Uh-huh.
and we decided the filming we did was with True to Nature. They're a British company, and they there's a lot of taboo and different things in Hawaii and culture-related issues. And being from Tennessee, why is this talking head from Tennessee here when somebody from Hawaii is working in the system? All of our permits run through her, so we decided that she was just going to be the voice of our research.
Oh, nice.
Yeah, so you see me and I'm like, acting away in the background, but I'm actively part of the research.
Okay.
So yeah, just not the talking head.
Totally off subject. I know what the words aqueous geochemistry means. But what the heck does that mean in terms of a job?
What is that? Okay, so I'll back up. Hello, I'm Annette Engel, and I have a bachelor's in geology. I have a master's degree in geology. I have a master's in biology and a PhD in geology. And the PhD in geology was interdisciplinary, so I wanted to marry geology and biology with microorganisms and chemistry. So it's sort of a big square of disciplines: geology, biology, chemistry, a little bit of physics, a little bit of math, a lot of computers. So the title of my professorship at UT is the Donald H. and Florence Jones Professorship in Aqueous Geochemistry. So Don Jones was a alumnus of the UT, and he went off to the oil patch, made a ton of money, and gave a lot of it back to the university, and he endowed a professorship. He endowed one in the aqueous geochemistry, I'll explain what that is, and they endowed another one in hydrogeology. So another professor has that position. I used to work at Louisiana State University, and I got a call one day from people here at UT that said, hey, we're looking for somebody that does geochemistry of water, and that studies the chemistry of the water and the microorganisms of the water, and you seem to be that kind of person we're looking for, and you're a woman, and we need to diversify our geology department. Would you be interested in coming here? And I told my husband, who's sitting back here, Scott, he goes on all these trips and stuff with me, and I said, should I apply? And he said, yeah, didn't you already send your resume in? So they hired me here. And so I teach geochemistry, which is where geology and chemistry meet, the rocks and water that interact together, and then the microbiology that uses the chemicals in the water for their life, their lifeblood. So iron and sulfur and hydrogen and all the elements that are in water sustain metabolism of bacteria. The bacteria then excrete things back into the water. We all know this as contamination. Microorganisms can also clean contamination up. So that was sort of the vision. So I teach the sort of aqueous geochemistry. It's all low temperature, nothing sort of volcano blowing up sort of temperatures, right? That's 1,000 degrees or higher. I study stuff that's here at the earth where we live and breathe, sort of lower temperature. And then I teach microbiology related classes. I teach a class on geochemistry of oil. I teach general rocks for jocks, Geology 101. So that's sort of like what it means to be an aqueous geochemist. I have projects all over the place, all over the world. I study some projects I'm the geologist, the geochemist. Other projects I'm the geomicrobiologist or even the microbiologist. So the interdisciplinary part of the research is high. If that makes sense. Yeah.
How does the aqueous geology differ from the hydro?
So hydrogeology is a specialty that is more related to how water moves through the rocks in the subsurface, or they don't necessarily work with rivers and lakes, that's a different field, but they work with groundwater and the movement of fluids inside the Earth's surface, and how to get water back out of the ground. Like for aquifers, for groundwater, drinking water, they deal with contamination, so the migration of contaminants in that water. So that's normally what a hydrogeologist would do. They don't concern themselves most of the time with the geochemistry. They hire a geochemist to do that. Yes?
How long are you underground at a time?
It depends on what the research's tasks are. So for some trips, we can go in and we know we're going to be inside underground all day. So we take water and lunch with us. So longest trip I've ever done is a 3-day trip where everything you pack in, you pack back out. Whatever you make, you take out with you too, if you know what I mean. So for most of the work that we do in the lava tubes, we are there for a very short amount of time because we tie the research that we do to our breaks. So spring break, fall break, Christmas break, Thanksgiving, that sort of time frame. And so we are in a cave in the morning and a cave in the afternoon for like 3 to 4 hours at a time.
Have you ever had trouble with claustrophobia?
Claustrophobia, no. I actually started caving when I was 12 years old. And I had been going to a lot of church camps and sort of the kumbaya, sit at the campfire. And I told my parents, I was like, I've done this for years and years and years. Mom, I want to go do another summer camp. And they were like, so there was a presentation at our church and they said, hey, come, it was called Venture Forth. And it was rappelling, canoeing, caving. And I was like, I want to do that. And then my parents drove me, a 12-year-old girl, to a camp in Kentucky and left me there for 2 weeks. And the rest is history. I still know the same people that I met when I was 12 years old. So we still came together, we still see each other, so, yeah.
two-part question.
I love your shirt, by the way.
Yeah, it's the
It's-
volcano.
Yeah. I saw it when we walked in, I was like, yes.
Are there a finite number of species whose root systems make it in the caves that are dominant? And the second one is, does each of those plant species roots have its own ecosystem of insects?
Yeah, those are good questions. That's actually in a grant proposal that I'm writing right now. A series of questions just like that. We don't know. So the ohia tree, you can see him sort of in the background that was featured in the video. That is the dominant tree that we think is responsible for the roots in these lava tube systems. That's because when you look at the surface, it's just a barren field of nothing with a few scraggly little trees on the surface. This landscape is 750 to 1500 years old, sort of in the background. And some of the trees could be 300 years old. The ohia grow very, 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 very slowly. And they're almost the only vegetation on young lava flows in Hawaii. And you see sort of, there's like grass in the background, there's a lot of invasives now. And there's also on the Hilo side of the island, this is on the sort of southwestern side of the island where we did all the filming, it's very barren. On the wet side of the island, there's the ferns, the big tree ferns, they showed it in one of the clips in the video. They also produce a lot of roots, but we don't seem to find those kind of roots. They're a very distinct root from the ohia, they're black, they're sort of straggly. These ones look like beautiful hair, they're very delicate from the ohia. We've done genetic testing in the areas where we see a lot of animals, a lot of the insects focused around the roots. Because where there's no roots, we've done the controls. There's nothing. We never see a single thing hopping, moving around, nothing. So most of all of the biology is associated with that root energy. And the genetic tests all come back that they're ohia. But there's also rapid ohia death that's happening in Hawaii. It's being spread by fungus. Welcome to another fungal disease that's killing things. I'm sure you've heard about salamanders and the bees and everything else. So the ohia becomes susceptible from the fungi depositing themselves and then basically eating away at the leaves, and then the tree dies very, very rapidly. So one of the fungal species has pretty high pathogenicity to the tree, and then there's another fungal species that's less pathogenic. And if you get the worst one, it's like within months that the ohia trees die. So our research is really concerned about this, because if these cave ecosystems are dependent on the ohia roots, then what happens when those trees die? And we see patches of cave where there used to be flourishing roots, and they're all dried out, and they're dead, and they're on the ground, and we don't see any life. So we could be seeing that sort of succession that would take place over thousands of years, taking place within a decade, which is sad.
So
Yes.
are those fungus that are affecting ohias, are those surface fungus?
Surface fungus,
How
yeah.
about any fungus in the lava tubes and what they might do, since we have lots of bats dying from a fungus?
Last week, we just got back data that we were trying to make sure that we don't see the fungus on the roots in the caves. We don't see it yet, at least where we're studying. So we're studying sort of the southern, anybody ever been to Hawaii? Maybe a couple people. It's shaped like a heart. We study the sort of tip. Ah, I can draw. Let's see if I can draw.
This is the Big Island.
Big Island. The sort of Mauna Kea, Mauna Loa, Kilauea. I think it's more sort of, I don't know. I should have thought about how to draw Hawaii before I got here. I think it goes like that, right? Yeah, sort of like that. So we're down here at South Point Ocean View, the largest subdivision in the country. It's like it was built in the 50s for like 10,000 people, and only 300 people live there. It's just miles and miles and miles of roads that are abandoned. It's a really creepy place. And then, so there's Hilo over here, and then we've studied lava tubes here, and we studied lava tubes here, and there's a group of lava tubes on Mauna Loa, and then there's another older volcano that we're gonna hopefully study this next year. So the rapid ohia death is mostly in the wet area so far. There's a little bit down here, and and a little bit to the northwest of the island, yeah.
So question on the invasive species,
Mhm.
are they affecting also the health?
Yeah, so in some of on the wet side of the island near Hilo, some of the lava tubes that were studied 30 years ago. So the first discovery of an animal in a cave, a lava tube in Hawaii, was in 1972. So I was born in 1972. So we haven't known about these systems for very long. I'll just put out there that I'm pretty young. So over the last 30 years, we've seen changes in the ecosystem based on the early descriptions, and we think that some of that is due to the invasive species, because we see millipedes like we have around here. They're called hothouse millipedes. We get them in your basement. We also see the sort of roly-polies from the surface are now in the subsurface. They wouldn't normally be there. They're getting carried in by hogs, bog hogs. They're getting carried in by cats and animals and stuff into these caves. Now we're seeing these sort of invasive, non-native animals, like the cave animals, being replaced by the surface bad invasive stuff. If that makes sense. That was kind of a wonky. She has had a
Okay, two-part question about
Yeah.
the structure of the caves or the lava tubes of the volcano. I'm totally naive about volcanoes, so I'm wondering, in the pictures, it looks like there's a tube, stuff comes out the top. Apparently not. Apparently there's lots around the sides. And if so, do you need more than 3 days to discover the depth of your tubes?
Yeah, so it gets even, yeah, so when a volcano erupts, the types of volcanoes that are in Hawaii are shield volcanoes. So they just sort of ooze lava. It's like the viscosity of ketchup, a little bit runnier than ketchup, like really sort of warm ketchup, sort of just kind of oozes. You see the rivers. Last year, around this time, Kilauea stopped erupting, parts of the Kilauea system. And it looks like it's flowing very, very fast. It's because it's over 1,200 degrees Celsius. So it's just molten rock. As it starts to cool, it gets thicker and thicker, sort of like molasses. So the middle part of it is flowing very quickly. The outer part of it is cooling. And so as that cooling crust forms on the surface of the lava, the interior just keeps flowing away and away and away, and then eventually when all the lava drains out and the volcano stops erupting, you end up with this crust of lava, of the salt, the rock, that's hollow inside. That was where the river of lava was once flowing. That makes sense. So it's amazing. Some of the lava tubes that we've been in are like subway channels. Huge, huge, huge. They were very close to Kilauea. There's a cave system called Kazumura. It's the longest lava tube in the world, and it's over 70 miles, 74 miles long. And it runs from Kilauea volcano, sort of that part of the island, almost to Hilo, as far as like where it runs. It runs literally the whole length, and there's side passages and stuff. As the lava flowed down the slope, particularly where it got steeper, the lava sort of, it's called anastomosing, it's a fancy word, but it's just sort of meandering and networking around. So you get these big, huge subway channel tubes up closer to the volcano center, and then down sort of as the lava is draining out to the ocean, you get these mazy, smaller networks. On Mauna Loa, some of the lava tubes there, the one system that we worked in and the one that was in the video, is the Kapuna Kanahina system, and it's 43 miles long. And the continuous part of it's broken up, like because of the weathering and erosion over time, but it's like 28, 27 miles for that section, and then you have to like go on the surface and then go in another cave and then come up and then go in another cave until you work your way up to the top of the mountain. And they flow, it's 1,000 feet elevation change from the upper caves that we can get to sea level.
So the life forms change in those.
No, they stay the same.
Come on.
Yeah, because the ohia is the whole, all of the elevation. Ohia, the other thing that's awesome about this tree is, maybe this is like the tree presentation. The ohia grows up at 2,500 meters, so 7,000, 8,000 feet, all the way to sea level. It grows on the dry side of the island and the wet side of the island. So for the lava tubes, they're pretty much the root systems are the same plant all over the island. Now, geography, splitting out populations, remember back to your like high school biology, how we get species. The organisms that we find, the animals that we find in the southern part of the island are genetically different than the organisms in the northern part of the island, even though they're all based on the same ohia food source. So that's kind of cool.
Wow.
Yeah.
How about the organisms as a function of elevation? They change?
No, they don't seem to change within the same system. So we think that the animals, so the one system, 750 to 1500 years old. That's the age of the rock. So what's great about lava is that we have a time capsule. We know when the volcano erupted, and we can age date the rock very precisely based on carbon-14 dating of trees that were trapped in the lava. We can date those trees, and then we can also use isotopes within the rock, like iron and manganese give us an age constraint, and uranium and lead and some of the other elements give us very tight age constraint. So we know the age of the rock, and we know that some of these animals have been on the island. So the island of Hawaii is only about half a million years old, 500,000 years old at the oldest component. But it's just stacked up lava tubes. So that early island, the baby Hawaii island, had lava tubes with ohia. Ohia have been involved for 4 million years. They're on all the islands in Hawaii. So you just get the stacking, and the animals, they leave where the lava flow is too hot, right? They'll burn up. So they just migrate to other areas where the lava isn't flowing. So you end up preserving these patches of history in the populations of the insects throughout these lava tubes of different ages. I know that sounds really complicated, I'm sorry. That was confusing, but it's just time is layered on top of each other, and the evolutionary processes are causing the animals to evolve through time, and we have that snapshot because we know the ages of the lavas. So we also then know the ages of the animals evolutionarily. Yeah.
Other volcanic areas presumably behave somewhat similar?
Yes.
Have similar species evolved there?
Yes, so the Canary Islands, haven't been, but it's on the list, is the same. They have a lot of volcanoes. They're all volcanoes for the most part, and they have cave-adapted animals associated with roots, but different types of trees there. So the base of the ecosystem seems to be the roots from the trees, and the animals that feed off of those roots are typically the sapsuckers. The plant hopper that they showed in the video that got eaten by the caterpillar, there are subsurface cave-adapted plant hoppers. I'll show you a picture of one. So you have the...
So could one from the Canary Islands breed with one from the Hawaiian Islands?
Probably not, no, they're different species.
They're that different.
Mm-hmm. So this is one of the cave fauna, they showed it in the video. And my colleague made a composite of the surface, different types of surface. Olearis is the genus, and the cave adapted is a completely different species. The surface ones are all over the place. There's like 18 different surface varieties of that genus. But notice the longer legs, the longer wings, the pigments, big eyes. The cave adapted one, this one's called Olearis polyphemus, and it has almost no wings left. It's completely, it doesn't need to fly, it doesn't need to go anywhere, it's always crawling on the roots. And then this is actually its antenna, it's not an eye. So it's completely blinded, and it sucks sap out of the roots. And the adults of this species suck sap out of leaves. And only the nymphs, the juvenile plant hoppers, suck out of the roots. So they completely adapted their diet and then their morphology over time. I don't know, but yeah.
Last month, Stephen Len Bales told us about cicadas and the nymph forms underground are sapsuckers.
Yeah.
And I'm wondering, since these roots are exposed, if it wouldn't be a good laboratory to study the nymphs because you see the roots.
So this is an adult plant hopper. The nymphs look like this one that I just had up here. You can tell them apart because of the waxy extrusion that they use, and then they build this nest around them to protect them from predation. But they both feed on the sap. in this species of plant hopper. And the normal plant hoppers would not do that. But that's because all the food is, all they have is roots. They don't have leaves underground, it's dark.
So the main problem with my idea is that there's evidence that the cicadas are kind of species specific, and they may not even be interested in the sap from these roots.
So plant hoppers are pretty fascinating. Like cicadas, they have sound. The plant hoppers also have sound. So in addition to the DNA work that's been done, there's also been studies where they listen to them tapping during mating and like trying to find mates under it's dark, right? You feel something on the root, you don't know if it's a buddy or a predator, right? So they have like certain types of tapping and clicking that they've recorded, and they're species specific. And across a big island of Hawaii and all the different lava tubes, the different species of plant hoppers do different things. So we know that they're even species within a species, like they're subspecies. It's pretty cool. It's crazy to think. I mean, we sat there for one time like, hear it? We don't hear it. It's way above our hearing capacity. Yeah.
Have you seen any evidence that any of the species are doing any kind of echolocation to find prey or navigate?
So, other than what the plant hoppers are, they call it singing, like the cicadas, they sing to each other. Crickets also do this in the caves, like they do on the surface, but they're distinct from the surface. The cool thing about the lava tubes is that the surface animals still exist. So in some cave, some of the hypotheses of how cave adaptation and evolution takes place is that the animals that are in the caves sort of are the relics of whatever that species used to be, because there's nothing on the surface that is there now. So like around here in Tennessee, we have cave adapted animals living in caves, and they went underground probably during the last ice age, when their ancestors died off. And now we're left with this relic population in caves. With the lava tubes, because these systems are so young, the surface animals are just fine. There's nothing to kill them off, other than the volcano. But then they just fly away or move away or crawl away. So we have this really cool story of the cave animal and the surface animal, and we can compare them. We can compare their singing, we can compare their genetics, we can compare their morphology, their shapes and their color and all this other stuff, their diets. And so we have this really interesting story between the lava tubes and then the surface. At least in Hawaii, Canary Islands, the question was where else? In Australia, we have very similar systems on different kinds of roots. Eucalyptus trees are the sustain the root systems in caves in Australia. Let's see, where else are the roots? In Mexico, not an island, but there's in tropical forests, the forest trees sustain cave animals in normal types of caves, like caves around here in Mexico. Reunion Island, so another volcanic island in the Indian Ocean, has lava tubes and it has plant hoppers and roots and all that good stuff too. So this isn't just a Hawaii phenomenon, it's happened all over the world.
So if you've got a sterile tube that's recently cooled, how does the you explained how the plants do it, but how do the animals?
So one of our colleagues who was one of the original discoverers of these systems in Hawaii, he went into, so the eruption, let me back off. Last year, right, Kilauea is erupting, lava flow, and it's very, very hot. When we were there in March, so it stopped flowing in August of last year, right before we went to do the filming for the video, for the documentary. We were there in August, and it literally, the volcano stopped flowing lava right when we got there. It was so sad. Because it also started erupting right after we left in March, so we missed the whole thing. We were there 5 times in a year and missed the whole volcano. So, darn, right? But we drove over the field where they had opened up the road, and it was still so hot. Like it was still, it's gonna take 40 years for the thickest part of that last eruption to cool. So one of my colleagues, he convinced the National Park Service during the last sets of eruptions in the pool event, where you could like hike out and see the lava going into the ocean, and it was like this big famous thing that was going on for like 3 years or something like that. There was a cave, lava tube that formed in that flow, and they waited for 3 years so it could get cool enough, but they still had to wear cooling suits in order to even go into the cave. There was, of course, no life in it at all, because it was still so boiling. He said it was sweating like crazy, even though he had a cooling suit on, everything was melting, it was impossible. So we have to wait a long time before we go into these systems. So fast forward through time, or back forward, go back through time. Our colleague went into a cave that had formed in the 1990s in the national park, the Volcano National Park, and it had plant hoppers in there on tiny little roots that had just penetrated through the surface. So it doesn't take long for them to follow the food, we think. And they're already cave adapted, which means they came from somewhere else, right? They didn't evolve right there, but they came from all the little
So they can leave
holes.
the tube,
Yeah,
go to the
crawl through
outside, and then get back in.
We don't think they would go to the outside because there's no food for them, especially if they're adapted to eating now a diet on roots, the way that the sap and the diet is, how would they survive on the surface. Here they have 100% relative humidity on the surface, they wouldn't. So we think that they just crawl through cracks within the lava field itself. There's all kinds of cracks and holes and little caves that we can't get into, but for the animals, as long as there's food and the roots of the trees provide that pathway, they can just go through the forest underground, basically to another area that's open. That's the hypothesis. And the genetics that we're reconstructing from these animals seem to make sense. There's clusters of genetic diversity, which meant that there's a family tree that can be built from this information. Yeah.
What value are the exposed roots providing to the tree?
That's my second part of the proposal I'm writing. So
you don't know yet?
We don't know. So I was fascinated. So when you look at these roots, you can kind of see it maybe in this picture. I'm an aqueous geochemist. So I see water, I see fluid. I want to know what's in it. So there's a lot of things that the root could be splitting out, right? Exudates, that phloem and xylem, the biology 101, your high school biology of how a plant lives. The roots are where a lot of that stuff goes out because the root is going through the soil and it needs to lubricate the path for the root to grow. And so they make a lot of sap through the roots. And so I'm like, is this just sap? The plant hoppers and the other sap-feeding animals, when they jab into this root, the pressure of that tree's flowing fluids inside of it is a really high pressure. So when the animal punctures it with a straw, that pressure is going into the body. And rather than shoot themselves off, what they do is they excrete a substance that they metabolize. It's called honeydew. It can either be liquid, or like this juvenile, he's basically turning it into a wax. It's so carbon rich and so dense that it actually comes out of him as a wax instead of a juicy sap. So like these insects are crazy weird and cool at the same time. So it's like, all right, is this water? Is this tree sap? Is this honeydew from the animals? What is this? So we collected it and did it drop by drop by drop by drop by drop, so we can get enough to analyze the carbon chemistry, the organic chemistry, and the inorganic chemistry. And so far, there's a lot of water in it, and there's also a lot of tannins in the material. And I was just telling my husband yesterday in working on this grant proposal that the Ohia make a special type of tannin that is also antimicrobial. So yeah, so it could be, because normally if you have all that organic matter and juicy sugar sitting somewhere, you're gonna be covered with bacteria, right? It's like, leave a cookie out and see how long it takes to get coated with junk. So in these caves, we don't see that. And we think it could be that it's an antimicrobial thing, so it's a hypothesis, we'll see.
Some plants, or a lot of plants, have these mycorrhizal.
Yeah, fungi.
That are symbiotic with them, and you see that.
We do see that there are some fungi. Now that, I put up this really cool picture of, so you can get an idea. Here's me with my sample, so you can see how dark brown that is. So those are drop by drop with a syringe needle sucking drops into to get about a milliliter of material from the roots to be able to analyze it. But when you zoom in, you can see, I didn't put it in here. You can see hairs. So here's some drops. And these are all fungi. We have no idea what they are, but they're not the bad ones. We do know that. They're some sort of in the Ascomycota. I don't study fungi. I
I
play.
think my daughter had to count them on reading for the lab, so
Oh,
that's how.
you could use somebody like that.
Yeah.
It's probably- So, yeah. Yes.
I've got a string of Hawaiian Islands, and so the oldest one, it's not underwater yet. Have you thought about running examining water tubes on those?
So the erosion rate is so high on some of those islands. Kauai is the only one, is the oldest one in the chain that we know still has lava tubes left. And they actually have similar cave animals that we see on the Big Island, the youngest island. And genetically they're related to each other, but our island, they're different species than in Kauai. In Kauai, there's a wolf spider, a cave adapted wolf spider, big ol' honker. Talk about when we were talking about the tapping, they will make, just like wolf spiders here, they like make a web of string, whatever you call it. Silk, yeah. And English geochemist. I don't know that kind of stuff. And so when you walk through the lava tube, you're like, you see your light catches the edge of that silk, the webbing, and it's basically a trap that it's set. It's not going to catch us, but I mean, these things are huge. So that in Kauai, in the lava tubes, is federally protected as an endangered species. On the Big Island, we know its genus, but we don't know the species yet. That's like being studied. And we think that they're different species. There are probably at least 5 different species on the Big Island. Where on Kauai there's one, it's endangered. On Big Island, more species rich. There's also a amphipod, like a sand flea, basically, that's in Kauai, and it is extremely weird. And we have them. They didn't think that they existed or they were able to evolve in the lava tubes in Hawaii on the Big Island, but they did. And I thought I had a picture. There on Kauai, it is federally protected as an endangered species, and on the Big Island, we have no idea what it is. So this was found like 2 years ago. There's species, like, in the video, that was the world premiere of that thread-legged bug. Like, nobody, other than that we knew that they were there from before the 1970s, we didn't know the species, we didn't know any of the other caves where it existed at all.
Do we have a species count yet for the caves?
So for the whole state of Hawaii, we have about 150 cave animals that not all of them have names. On the Big Island, it's about 50 so far.
Most all of these are, what, insects? I'm not sure.
They're all insects,
Okay.
yeah. There's no bats, there's no spiny animal that lives in, there's nothing with a spine, no vertebrae. So we don't have salamanders, we don't have bats. There's bats in Hawaii and there's salamanders in Hawaii, they're just not cave animals. Yeah.
Any microbes?
Yeah, so the cave walls can be covered with really pretty yellow and pink and white biofilms. And there's been a couple of researchers from the University of New Mexico that have studied the microbial diversity of these biofilms. And believe it or not, the bacteria that live in those biofilms, in the lava tubes in Hawaii, are related to cave bacteria we have right under our feet here in Knoxville. Bacteria have been on the earth for a long time, and they've been gone everywhere, in the air, in the dust, in the water, and everywhere. They're ubiquitous in those habitats. So there's there's a few interesting sort of iron bacteria that are found in the lava tubes that we don't see like around here for bacteria in caves. But for the most part, the cave microbiology is very similar to everywhere in the world.
So do any of the insects feed on biofilms?
So that was a hypothesis from the 70s. We have not seen evidence for that based on our work. So they didn't use chemistry, they just watched the animals who ate who, you know, oh, that cricket just ate a plant hopper. Didn't know that they were predators, but okay, guess crickets are predators now. They eat plants, they'll eat whatever they have. But we don't see the insects eating the biofilms, and based on the chemistry that we've done of the food webs and how the ecosystem functions, we don't see evidence for it. But it would be logical. It's carbon, it's food.
Did you say iron bacteria?
Yeah,
So they're making a living on iron 2, iron 3 transitions?
Yep, out of the lava, the minerals that make up the basalt. Yep.
One crazy question for you. Your department is Earth and Planetary Sciences. There's theory that there may be some lava tubes on Mars.
Yes, I just saw this report today from, I think it was the USGS, released this Caves on Mars report. Lava tubes. They're lava tubes, not like caves. Caves around here are in the limestone rock, carbonate rock, and the lava tubes in basalt. Mars is mostly basalt, and then with sedimentary rocks on top of all that basalt. So all of those volcanoes on Mars probably produce lava, and that lava probably had lava tubes. So
They're shield volcanoes.
they're shield volcanoes, just like, I mean, it's kind of like, you know, physics works on all the planets the same way as it works on Mars. So the geological processes, how things work, everything works the same. So the report had, gosh, I don't remember how many caves that they think that they can see from the orbiters. You can see the entrances from satellite imagery like you can here on Earth, and they mapped like 500 proposed entrances on Mars. And that was today, they released that report. I think it was 500 something, it was a lot. Yeah, it's crazy, huh?
Yeah.
Let's go.
What else are they doing in the caves, research-wise, if anything?
So we're mapping, so I'm on the board of directors for the Cave Conservancy of Hawaii, and our goal is to map the caves and put out, as part of our mission, the education and information to all the locals. One of the problems with the lava tubes is that they're a really good place to store trash. Just like here, our caves here, right? Sinkholes filled with trash. Entrances of lava tubes in Hawaii filled with trash. So we do cleanups, we do info sessions, we have boards in the big area, in the neighborhoods where there's a lot of lava tubes. And there are lava tubes that run under people's houses. Their septic system, instead of going to a tank, goes straight into the caves. So there's a lot of information.
It's the plumbing system for the
Oh, you
island
can
also.
smell it, yes. They dump dead animals, road runoff, so there's a lot of rain on the Hilo side, and so they funnel a lot of the road runoff with all of the contaminants and metal right into the caves. So there's just a lot of education that we have to do and outreach there. But in order to know who to outreach to, we have to map the caves. We need to know where they're at. And for some of them, they're pretty obvious. They're big subway tunnels and they have huge entrances. Some not so much. Some you don't know. You just know that this is the lava flow from the something 1881 eruption. So this rock unit should have lava tubes in it somewhere. And so there's been ground penetrating radar that they've run across some of the lava flows to look for hollow spots. And then they do test wells and they're able to find caves. And then they're able to tell people that there's a cave under here, don't build, you're gonna lose your bulldozers, don't put the road here. I mean, I literally like stuff that should be obvious is what we're doing. So that's the sort of like what we're doing that's not research in the caves or on the caves, but about the caves and trying to get that out. So, and then obviously the science, biology, chemistry, there's meteorology people that work in the caves because they're interested in how wind moves around. There's geophysicists who are interested in how the rock is cooling. So over in where the lava flows are newer, they actually are still cooling, and so they're looking at how the actual lava tube in the rock responds to the cooling. Yeah, there's a ton of research is being done with lava tubes. It's not just biology. Thanks.
Follow-up question. I'm just curious about the ground penetrating radar. I know it exists, but I don't know a lot about it. Is it aerial, and what's the radius on that thing?
So the aerial flights like LiDAR don't penetrate below the surface. So, but you could see subtle, like a hole that you might not see because the forest has grown over it. So there's been a little bit of stuff that they've done with LiDAR to look for cave entrances. But the ground penetrating radar is basically you have stations that you put along, you have sound, like bang on a rock or metal, and then the sound waves are captured in this sort of geophones, and then they're able to map what's going on. And where the sound doesn't go, it's probably because there's a big hole down there. So that you can figure out where the sound is traveling through and where it doesn't to find the lava tubes. So it's pretty cool.
It is really cool. It sounds really hard to set up though. Like,
Yeah.
I can see why it wouldn't be able to.
Well, that's where you have to know, this is the flow, this is the rock, let's focus here, let's run the transects in this neighborhood. Don't have anybody else banging away on with a jackhammer or something the same day you're running a test. So, yeah.
I heard that some lava's light enough it can float. Could you get, what's the variation in densities? And then some of it's like glass.
Right, so the pumice is the stuff that floats. So that's welded ash from eruption. The volcanoes on Hawaii don't erupt in that way unless there's water involved. It's to make an ash deposit. Most of all of the volcanoes in Hawaii, thinking of maybe on Oahu, Diamond Head is a little bit different because it formed at a later stage after the island of Oahu already formed. But the Big Island is basalt, and it's typical basalt. I don't know what the density of it is, but it's, I have a figure from my Geology 101 lecture that I could, in my head, to show you. 2.67 grams per centimeter cube, like a normal rock.
As compared to what
So-
obsidian would be then?
So obsidian is glass. So it would be when the lava flow reaches the ocean and cools, quenches, that's when the glass forms. Like, you know, we can go downtown to the Pretentious and see the glass flowing. Same idea, where if you cool it really rapidly in water or some sort of solution, it will shock, all the crystals form right away.
They don't form.
Huh?
They don't form.
They don't, well, they're just
If
very.
it's quenched, if it's
yeah,
quenched, it's amorphous.
Quenched, yeah. So, we don't really see that in the lava tubes, except in some areas we see where it's really shiny, that it's got a crust of obsidian, where it may be like a rainfall ran through the system as it was cooling or something. But most of the time it is just jagged, and we call it glass because it feels like it when you put your hand on it without gloves. I brought stuff to show you guys that sort of how we gear up to go into these systems. It's not like caving around here where you can just go in with tennis shoes and a flashlight, and you know the rock's kind of soft, you have to crawl, you're not really gonna hurt yourself. Crawl on that, like that is rough stuff. It eats boots, eats gloves, eats elbow pads, eats everything, pants. I have this great picture of, we have, you know, when you go on these field trips, you know, you only have the gear that you can fly in with, and all of our gear is dedicated. You can see all the patchwork rear ends. And then we also have to duct tape all of our boots because the tips of our boots, because we're pushing through when we're crawling, they just get shredded. So we put duct tape on them every day. We use silicone caulk.
In the video, it was just plain old blue jeans, so.
Well, we do wear cheap old blue jeans. Like, so we either go to like a thrift store or we just patch the blue jeans up. So like this woman here, she's native. She's not native, but she lives there. And those blue jeans have seen probably 3 patches just welded on there. So,
Checked into Kevlar gear?
so the gloves that we have are Kevlar. We use Kevlar.
How about knee patches?
Knee pads, we use the welder's knee pads, or the sort of handy dandy thick. But this was like one trip.
Yeah.
So, I mean, it just gets all completely eaten up. So we have dedicated gear for the Hawaii work versus the work that we do around here, just because we don't want to introduce anything weird and infectious from here on islands. So this is all of our gear.
Plus your boots.
The boots,
Pretty bad.
boots are also dedicated,
Pretty bad.
but I'll show you what they look like after a few field seasons.
Oh, wow, look at that. Oh, my goodness.
They're not the worst boots I've ever, but these were brand new.
You do that.
Well, I was at some point.
Yeah, well, I mean, like, this was, I got these back before our March 2018. And two trips. Two, like, caving every day for 6 days straight. Yeah. And then we also, with the local group, so this picture that was up earlier, it's really, hui is the Hawaiian word for team. So we decided that some of these guys are in Hawaii all the time. Some of us are from Arkansas or Tennessee. So we decided that we just wanted to brand our group. So we made bags that were dedicated to the field work there. So, you know, it's recognizable, it's pretty, it's nice. They're also really handy because you can just, got your notebook right here. I got got my water, got my research gear, so it's all tucked in here.
Carry that in the cave?
Yeah.
Just
I
like
usually
that?
carry more than that.
Wow.
I usually carry more than this. I usually carry back, like in the video, where you see us carrying like 2 bags, that's my normal gear, would be another backpack. Biologists get to carry less, camera, snacks. But yeah, so, and these are made by a caver, where's Cave Skins? Texas? It's a Texas person who makes those. And then of course our helmets, oh yeah, our elbow pads. Gotta protect your elbows when you're crawling because it's just sharp rocks. Normal helmet, dedicated 2 sources of light, plus we have another flashlight. But you can see it's very light. Pass it this way. So those have batteries in them, but they're also very bright. It's very hot in these caves. So average temperature on the surface is like in the 80s. It's also that inside the caves. So, yeah, sweat. So we wear t-shirts and just 1 layer of pants, and if our pants rip, we just show it until we get back to tape them up. It's just, or the shirts, there's a passage we went into, it's a squeeze, and it's, squeeze in through there, and your clothes just basically stay on the rock behind. Like as you move forward, your clothes stay behind. It's terrible. It's called the shred.
Wow.
These gates are basically open and closed in.
There's
It's just that
some,
you don't know where.
we don't know where the end's at.
So, which would explain the temperature staying the same.
Yes.
Because you just got the air popping in from outside.
Yeah, and there's a lots of cracks probably. Again, the animals are getting in somewhere and moving through the system over time, so yeah.
So how deep would your typical excursion into the cave be from an open?
For the mapping portion of it, we will go till the end of the map that the person drew before us and then start mapping from there. So that might take 20 minutes to get to a part where they left off, might take 6 hours.
Yeah.
Like, it just depends on how deep into the cave. For some of the biology work, we pick sites that are like no more than 45 minutes to get to where the roots are. Or like an area of the cave that, there's a lot of people that go to Hawaii. Some of these caves are tour caves. And so there's some areas of caves that are very heavily trafficked, but we can still find biology. But it's so overprinted by human impact and everybody going, ooh, aha, looking at the same thing day after day after day. So we go further in.
And do you see the same distribution of species all throughout?
Yep.
It's not like they get fewer as you get deeper in or anything like that?
No, there's roots. So it depends on how, the most we have rock-wise above the cave where we have roots is about 30 feet. But for the most part, the lava tubes are shallower than that from the surface.
30 feet.
Like 30 feet is sort of our maximum depth. So if the lava tube, and they parallel the surface of the volcano slope, so generally it's just layers and layers that are at that same depth. So we just follow through, yeah.
GPS that's underground?
No, compasses. We're surveying with compasses, and in these caves, in caves around here, we'll do front shots and back shots, and then, you know, laser distances and stuff to like measure heights of ceiling and the wall. But in these caves, the compasses, if you get close to the rock, they go, because the iron in the rock is using the compass. So all of the survey passages, we might label the floor or the ceiling, but it's all at sort of eye height is where we do all the surveying, because that's the furthest away we can get from the rocks. So that's how we survey, by hand compass, sometimes with the tape measure, like old-fashioned surveying. It's hot, we're not carrying all that stuff in there.
So you measure the angles with something else?
We do back sights to make sure that they match. And usually on a survey team, the same person does all of that day, or at least all of that section, so there's consistent ways that they hold their eyes to the stuff. So, I mean, it's very, argue about each other's, you know, your drawing isn't very good, or were you blind that day? You know, it's like, yeah. I like to do the sort of point. I don't like to do the drawing of this.
Is there anything at all that might be called weather in this?
Yeah, so in some of the caves, depending on the entrance and at the higher elevations, if a storm is coming in and a fog is setting in, we'll actually be in the cave and see that fog or that turnover, and we can see really interesting patterns in I put in here a picture from some of our temperature and humidity data loggers. You can see storm fronts come through. So normally don't use that. What did I do with it? So this is sort of the surface, a couple of data loggers on the surface, you see day, night, day, night, day, night. These are the caves. So that's sort of a mid-elevate, this is the sort of higher elevation ones, where it's nice and steady and cooler, and then we have the low elevation ones that are warmer temperature, but it's almost no change, except for little blips, like really hot periods during the day may come in, so you see that if there's a temperature inversion during the day, you'll see that as a fog inside the cave, and sometimes you can't even see. Yeah, it's pretty crazy stuff, but they breathe because
You
of
risk
the pressure.
a flash flood while you're in there?
In these caves, no. Caves around here, it's high potential. Yeah, it's a risk. But there, none of these. Hawaii doesn't have a lot of surface drainage, a lot of rivers, not a lot of streams that are formed because it's really geologically young to develop that. And when it does rain, it just goes right through the rock. So we don't see flooding. Yeah.
In surveying, can you use your in the cave, can you use one of your humidity, temperature logs with the barometer to get elevation changes?
Yes, we could do that. Yeah, so one of the colleagues, he's from Germany, and he does all the sort of meteorological stuff. This is mostly to log where the roots are and where we're sampling the animals, just to see how it used to be. The hypothesis was that the caves are the same, there's no change, it's always the same temperature, there's nothing dynamic that happens. They change, they breathe, there's air moving through them, sometimes there's enough wind that you can see the roots like blowing, like hair on a horse.
Wow.
I mean, they can be strong winds, but then sometimes you go in there and it's calm, dead calm. So they're very dynamic systems, and now we have the ability to log that and show it. So, yeah.
I can see that the basalt is porous, but I cannot understand why water stays in it, why it's moist, why the whole lava tube is filled with moisture.
The sort of high 9% relative humidity.
Yeah, because the roots are big in it. Why does that stay? Why does it not just dry out?
I don't know.
That's the
It's-
third proposal.
Yeah. that might involve somebody that does meteorology. It's like one of those things like caves, we just tend to see that all the caves, even around here, have 100% relative humidity. and it's like pegged, like, but there's not even when the wind changes or anything, you don't even see it change. It doesn't change at all. Yeah, I don't know why that is though. Yeah.
It's sort of interesting that the only tree that seems to grow there is the
Ohia.
And after all of these years, why isn't anything else proliferating there? It's interesting.
There are other trees, so koa and eucalyptus, which is an invasive, koa is a native. The tree ferns grow there, and they can be this big around. But on the lava flow, that first pioneering species tends to be the ohia. It can, and there's a lot of research being done on why. It's genetic, it has a lot of, remember it grows from high elevation to low elevation, it grows high rainfall, low rainfall. It can grow under nitrogen limitation, it can grow under phosphorus limitation, it can grow under water stress and nitrogen limitation, it can grow on nitrogen, it can put fertilizer out, and you don't water it, it can still grow. I mean, like, it just has such plasticity, we call it, as far as how it can live, that it's done this. And it's the dominant in the forests. As far as like if you took like a Landsat imagery of the island, of the Big Island, or any of the other islands, ohia is the dominant tree in the forest. And they can grow for very long periods of time. They grow about 1 to 2 millimeters a year. So they're very slow growing. Like, don't plant one in your yard and hope it'll give you shade by retirement. Like, they all joke about it. Like, they all get these little seedlings and they're like, I will never see it get this big. I mean,
So
just
this way, 1 to 2 millimeters.
yeah, oh yeah, it's so slow. And some of the trees, like a tree this wide with this diameter could be 200 years old. I mean, it just, depending on the water availability, a 200-year-old tree on the wet side of the island may be about 1 foot in diameter. But I mean, they just grow so slowly. And some of the trees in our area near the ocean view, we think that those trees may be as old as 700 years old. They age almost the age of the lava flow, which is 750. So they're really slow growing and very, very ancient trees.
Do they grow other places besides the lava fields then?
So in the forest, yeah, they'll grow they just grow on the salt. And then as the basalt sort of weathers and the forest gets thicker and then other species come in. So the succession goes ohia, koa forest, and then ohia, koa, and some other tree forest, but then those trees die out and ohia stays.
They know where the ohia came from because they haven't colonized a lot.
Yeah, so the Metrosideris is the genus, and it is also in New Zealand, and they've studied those. They're different species. There's also a tree, it's basically in the myrtle family. It's very similar to myrtle family trees, yeah. And so there's some in Australia, and they think that this genetic lineage of these trees goes back about 40 million years.
Would that help with fungus if you could try to interbreed and get some genetic diversity?
Yeah, so that's really why there's such a risk, is because you have this genetically, it's like a clone. Like on the island, all of the trees at the same, all the forests are made out of the same tree. There's not a lot of genetic diversity. It's kind of like for bananas and some of these other crop plants, for agriculture, there's like a huge risk if there's an infection or a virus or wilt or something that it'll just come and decimate the entire stand. And your whole banana plantation will be wiped out because they're all genetically identical to each other. So there's been some work to try to understand the subtle differences in the ohia genetics to see if there's some variant that's less susceptible, but that's all like just recent. They found the fungus last year. They were able to genetically identify them. So this is all sort of hot off the press. It should be on the nightly news, this stuff.
Where did the fungus, have they determined where the fungus
Airborne.
came from?
It just blows in on the wind.
So it starts on a leaf?
It starts on the leaf, yeah. And it basically causes a canker that then causes the wilts that causes the whole thing to
So
die.
like dogwoods around here?
Yeah, it's very, very fast. If it has the high pathogenic.
I'm gonna ask the next to last question.
Okay.
So, when the tree catches the fungus and it dies on the surface, have you seen, like root systems that have died?
I haven't seen them yet.
Haven't seen them yet.
No, but they're, the Cosmora system over on the sort of Hilo side of the island that we've been working in, it runs right under people's yards, and we now have really good maps of where the ohia are infected with rapid ohia death and where the ohia trees have died from rapid ohia death. Because trees just die too. It's like there's other reasons why they die.
If I cut down a tree in my yard or
Right.
something, it takes years for the roots to die.
Right, so the same there.
Yeah.
So that's, we have really good maps. As of this year, the USGS is starting to put out the ROD, the rapid ohia death maps. So people know where the tracks are, and our lava tubes run under some of these areas. So one of the things we're going to do in November when we go back, if we're going to be in this area or back when we go in March, we already know we're going back to that area, is that we're going to use cave radios to locate the roots in the cave and the trees on the surface to be able to know that which roots are to which sort of patches of trees, and then be able to map them from satellite imagery, their health. So we don't have to actually be there watching the tree, we can look at it from the satellites. And so we have people in Arkansas that are doing that. Yeah.
So, last question.
Any chance of grafting some foliage from a healthy tree on roots of one of these
I think
decimated
people are
trees?
working on that. Yeah, the horticulturalists are working on that in the state. So the rapid ohia death came out in like 2010. There was the suspect of this, what is causing these ohia to die really rapidly, because there had been mortality in the 80s, and there was a big mortality of the trees back in the 50s, and they were always caused by something different. And the way that these trees behaved in 2010 and 2012, and then again in 2016, the spread was much faster than anything that they'd seen in the past. So that's why they started looking for like this fungus. So, and then they were able to identify it genetically just last year, within the year.
Do you know where it came from?
It's windblown, and they think it's probably Asian.
Makes sense.
Yeah, wind.
Everything else is.
But I haven't, but we just are starting to study that. It was awesome to brain dump to you guys as far as like what I know in Hawaii. I'm glad. Definitely watch the whole rest of the PBS special. It's pretty fantastic, some of the crazy stuff that gets done by the other people in the movie. That little segment is ours, is about 8 minutes long, and then there's like other parts of the series where they look at goats and other volcanoes, so definitely see it.
Let's give it a hand. I'll just give you recognize to the screen, we're here in the month of August, and this is on the ScienceCafe.org website. The newer meetings are towards the top, so scrolling up. Next month again, September the 19th is the date. That'll be sinkholes, and our speaker Susan Jalarecki. She's the professional geologist that works in the area. Again, well, I don't have a flyer yet for October, but the full title is Neutron Oscillation in Bearden. So that'll be coming up October the 3rd. Again, there's no speaker yet for November the 7th. That's the day, and then December the 12th. The title of that is Return of the Raptors. So that'll be December the 12th. We appreciate everybody coming. Before we close, I'm going to ask David Fox to come and just give a brief introduction to the Associated Professionals think tank. Let's give David a hand.
For those of you who are fact junkies, I've got some science factoids. I'm going to put them on the table here. You're welcome to take one if you'd like. And since a lot of you are returning, you may already have seen this, but I've got a little sheet on our think tank. Anyone who wants one that doesn't have one, I can give you one so you can find out about the think tank. Okay. The think tank back in the first of this year became a co-sponsor, which means we help pay for some of the goodies and so forth. So, but basically our think tank is a group of people who like to find out new things all the time. So we meet in my wife and my home, and we meet roughly once a month, this being our other meeting. So if you're interested, check with me afterwards. Thank you.
All right. Appreciate everybody coming out. And again, if you know people with young kids that might be interested in this, please let them know about us. Thank you all for coming. Have a good night.